to hearing about some of the things we can do about this situation after that
Just wondering how I
discussion.
share. You've asked me to share. What am I sharing?
No, sorry, Catherine O'Shea.
Sorry, wrong Catherine. Pardon me.
Sorry.
And we're both CO as well.
Okay. Right. Apologies. Catherine's just seeing if that's going to share. Often, yeah, Teams is a bit trickier, Catherine. That's why I was going to ask you now before.
Yeah, it's not sharing. I'm hitting presenter mode, and it's just not sharing. Content.
Asking for permission, Catherine.
It doesn't seem to be. No. Should I go to?
I have to go into settings and give Teams permission to share.
Okay.
Alternatively, if you want to email me the slides, we can do it that way. As long as I've got permission. Actually, I better check I've got permission.
Accessibility in settings. I've just got call health and accessibility. View. No.
Yeah, Teams does this sometimes, and it can be. I've had to abandon.
Recording.
Otherwise, can you send it while I talk? Do you mind only sending it to Michael? We're going to have to do that.
Yeah. Okay.
So Catherine, it's just Michael.HII.
Okay. Just hang on. I'll have to get out of that.
I'm just going to check that I can share before I promise that. Is my screen sharing at the moment? Yeah, great.
Yeah.
Yeah, so Michael.HII, Catherine at svha.org.au.
Oh, not at UniMelb. Okay. Sorry. I'll try again. Michael.HII at SVA, was it?
SVHA.
SVHA.org.au. Thank you, Michael.
So look, I guess I'll open the meeting. It's 4:01. There's quite a lot of people online. So look, thank you very much, first of all, everyone, for attending on a Wednesday afternoon. My name's Michael He, and I'm a surgeon at St Vincent's Hospital, and I'm really excited and privileged to kind of be part of this meeting. This is the first Melbourne University Sustainability Grand Rounds for 2025, and this is a collaboration between the University of Melbourne Sustainability Department and St Vincent's Hospital and our sustainability team. The former being at the moment in the setting of this meeting led by Ben Dunn and Eugenie, who I'd like to thank for allowing us to be part of this, and Terrell Bean leads our sustainability team at St Vincent's Hospital. So as always, just want to acknowledge that I'm dialing in from the lands of the Wurundjeri Woi-wurrung people. I want to pay my respects to any First Nations elders on the call, and just acknowledge that they've been amazing stewards of this land for 60,000 years, and something that I think we all should try and live up to. Just the housekeeping, we record these meetings. I hope that's okay for everyone. The meeting will be posted on our St Vincent's Sustainability website, and I do get a lot of emails in between these meetings asking for where these meetings are recorded. So if you want to share with your colleagues, please feel free to do so. I'll send a reminder after this meeting with the link for those of you that want to do so. There's a couple of email lists that we use to advertise this meeting. One is a specific Melbourne University one, and one is a St Vincent's one. Again, I'll share those links. Please join if you wish. I think it's a really important conversation that we have in this meeting, and I think it's really important that we turn volume up with our colleagues. As always, very, very keen to hear feedback, suggestions, or people that want to collaborate. You can email me directly, and I always answer all my emails at the moment still. Now, our next Uni Melbourne Grand Rounds is the 23rd of July, and at that time we're also going to be having our St Vincent's Sustainability Forum. Again, I'll share the information for those events and encourage all of you to come along. And just before I hand over to our speakers, I've just got a little reflection today. I was in the operating room yesterday and talking to one of my very esteemed senior colleagues, and he sort of knew that I was part of this gang. And he was kind of bemoaning a little bit the fact that St Vincent's was successful in removing nitrous oxide from our anaesthetic department. So now if he wants nitrous oxide, he has to wheel this trolley into the theatre. It's quite cumbersome. And there's many, many steps for him just to get nitrous oxide. And he was sort of bemoaning that because it's quite a good drug, and apparently. But it just sort of made me reflect and made me remember that whilst the people on this call think this is a hugely important topic and we work hard to try and do something to improve things, a lot of people still don't know why we're doing this. So having these meetings and having these conversations, I think, is really important, and it sort of informs us, but also helps other people get a bit more involved, seeing what they do, what we do, and trying to help themselves. So thanks again, everyone, for coming along and being part of this. Now, I've got two fantastic presentations today, and we'll get straight into it. The first main presentation is from Forbes McGain and his team from the Healthcare Carbon Lab through Melbourne Uni. Many of you will know Associate Professor Forbes McGain. He's either directly or indirectly been involved with so much in the way of healthcare sustainability in this state, even actually this meeting. He's got an AO for his work, and I think that's highly well deserved. So we're really, really very privileged and excited to hear from Forbes today about the Healthcare Carbon Lab and also some members in his team. Thanks, Forbes.
Sorry, can everyone see the presentation at the moment there?
Yep,
Michael?
Yeah, loud and clear.
Okay, good. So thank you very much for this opportunity to present Western Health and the University of Melbourne, the Healthcare Carbon Lab, finding the carbon footprint of common medical equipment. Catherine O'Shea and Scott McAllister are also going to talk, and once again, thanking the lands of the Wurundjeri people on which we are working. So some disclosures, various grants, Doctors of the Environment, and work with Monty Hood in the past with patents, and certainly very much acknowledgements from multiple people across multiple faculties and areas in Australia. We, as an audience, are probably already aware that an approximation of the carbon footprint of Australian healthcare is something similar to 7%, which is about the same as Brisbane. Hello, Cyclone Alfred. So it's about the same as 2 million Australians, all the things that they do, their food, their travel, their clothing, etc. So it's a large percentage, about half of agriculture, for example. And of that, look, this is an NHS UK look. I know it's a fairly simplistic look, but maybe it just gives you a bit of an idea that, yes, all those Scope 1, we talk about emissions, are important, anaesthetics being a small part of that. It's mainly going to be about burning gas for heating in Victoria, very much brown coal for electricity, Scope 2 in Victoria, and then the Scope 3 emissions, the big ones, being in particular medical devices and even more so medicines, part of the story there. And we'll talk about the importance of those in a moment. So those other factors are important, but medicines and medical devices. And just mention there, this is a photo of a happy anaesthetist in the UK, and no longer using desflurane, but getting rid of a high global warming potential gas like desflurane or nitrous oxide, as Michael has talked about, is actually relatively easy. It's focused, it's a few percent of the total, and you can work on that. Yes, there's controversy to some degree about that, but in the end, it's actually relatively easy to do. For other drugs, this photo here is one of our study we did of morphine quite a while ago. About 50% of the world's legal morphine actually comes from Tasmania. These are poppies in Tasmania, a good old Papaver somniferum. This is the rather strategic harvesting, as one could imagine. Imagine the aroma of that place. So this is harvesting, and you see the gum trees in the background there of Tasmania. I'm showing you this to say that if you're going to do a carbon footprint of this sort of stuff, it's a lot of work. And this is just one drug. There are 4 other drugs associated with Papaver somniferum, but it's a lot of work. And then you end up with these things in kegs, those kegs of morphine, for example. And then you have to go further and you have to work with other companies to come up with the final product that you might use as a doctor, nurse, allied health. And so I was just trying to show you photographically how much process and involvement, engagement with staff at various companies is required to do that. And similarly, I wanted to show you, here's an example of where a Dutch group fairly recently used information that finding out what the footprint of medical equipment now, remember we're going to talk about medical equipment as well, that's particularly going to be the flavour of our discussions. But what I want to show you is something that's sort of interesting. If you talk about the monetary value, and I don't know if there's any cardiac surgeons amongst us, but certainly there are some surgeons. You've got 363 there, that's for the year in Rotterdam, prosthetic heart valves. And that they've said is around 1% of the carbon footprint of the hospital, in total hospital. So those 363 valves, they've said is 1% of the carbon footprint. And yet 17 million non-sterile medical gloves, 17 million, that's actually very similar to Western Health, for the year, was about a third of that. Now, to me, that doesn't really make sense, but it makes sense if you're just going to talk about it from a monetary perspective, yes, but not so much from a carbon perspective. I can't see 17 million gloves being the same carbon footprint as 363 of those small stented valves. So moving right along, it's important to think about all of the waste and all the things that we use and the fact that we're trying to footprint those things. This is a very simple look at what a cradle to grave is. So when you're trying to look at any product, even a plastic water bottle, for example, there's a process of digging the oil out of the ground and using it and moving it around and either throwing it away or recycling or reusing it. And looking now with Scott McAllister, who's about to speak, it's now about 15 years ago that we did our first life cycle assessment. The important thing was not so much what our result was, but it's really that this was really the beginning of the journey. It was one of the very first done, but now it's quite exciting because many more people are doing similar life cycle assessments. So that part of the story is coming along nicely. And for those who are interested, it's well worth, this is a Canadian site, the database Healthcare LCA. This is more of this is not so much a library of stuff, but more, here are all the studies that have been done in life cycle assessment. And what I want to also point out is that it's global. In other words, the information is global. It is open access and it's living, and that requires money to do that. The Canadian Health Institutes have supported this, and it's based in Nova Scotia in Canada. A lot of work has been required to produce that. What it's not so much is actually what it seems to show here, which is different types of syringes. It doesn't necessarily give you, here are all the common things that you as a doctor, nurse, etc., would be using on a day-to-day basis. And that's what really we're getting engaged with in the Healthcare Carbon Lab. I know that there'll be further discussion in a moment, but I wanted to say that this is what I'm really excited about, is developing a database, a library, in order to further, in a simplistic way, develop further information. So where are we? I think there's been an explosion in clinician interest. I think there's a lot of work to do in medications. Now, I haven't focused on medications because I've just tried to show you that it's actually a lot of work and it requires the engagement of the pharmaceutical companies. So that's something where we're a little way off at the moment. But equipment is actually relatively easy because it still requires a lot of work to do, but you can actually work out what the stuff is made of, as Catherine will show, different to medications. Pathology and radiology are coming along nicely. We already know that energy is very important. And I wanted to just point out that all of these other factors like societies and colleges, the Australian Commission on Safety and Quality of Healthcare, as well as federal and state climate and health units, are coming along really well. There's some real engagement there. And also now we're moving into clinical pathways, but we still have much to research. And I'm very excited as a final little notice to say that we've just very recently received a $1 million NHMRC grant for healthcare sustainability research. First time ever that NHMRC has funded such work under health services. Thank you for your time, and we'll move on to the next speaker. Let me stop sharing.
Shall I try to start sharing?
You want to try again, Catherine?
I'll try again. Is that it's preparing my slides? Is that translating to you? Oh, thank goodness. Thank you. Thank you, Forbes. Thank you, Michael. Good afternoon, everybody, and thank you for having me. My name's Catherine O'Shea, and I'm the Program Manager of the Healthcare Carbon Lab. And today I'd like to share a little bit about my role in the Healthcare Carbon Lab. So my main project is working on an LCA database of medical devices. It's a very big vision and it won't be achieved overnight. However, it's based on real data and real products. The point of differentiation for our database is that we're using the life cycle analysis approach to analyse each product from the ground up. That way we can build a model of healthcare that offers wonderfully rich information to work with for decision makers and policy makers. To date, carbon analyses have been done from the national or health service level using economic data. So we see this approach as more appropriate for developing sustainable products, procedures and care pathways on the ground in healthcare. The data I'm presenting today is derived from HealthShare Victoria combined with procurement data from Western Health. So let's jump right in. This is the top 20 products we use day in, day out. And if you look at the volumes, they're quite extraordinary. This is just 9 months of data from 2024 with all the items kind of deboxed. And you can see that gloves are the leader by a country mile. It's quite shocking. Other things, forms were a bit of a surprise to me, particularly given that this health service has transitioned to electronic medical record some years ago. So obviously a lot of paper still manages to find a purpose. I feel it would be interesting to apply a health economics lens to this data too, matching things like wristbands and medicine cups to patient numbers and respiratory filters to intubations to determine how many on average we're using per procedure or per patient. I also wanted to offer you a more detailed example of the LCA process that delivers such great data. This project started some years ago by asking manufacturers what their products were made of, and I'd like to thank Ruth Davies of Western Health, who kindly donated her time to that phase of the project by emailing manufacturers and collating their responses. The current phase of the project is in the University of Melbourne Chemistry Lab, analysing each of these products to check that information. So we chop the product up into its component parts, noting its mass and country of manufacture. Then we analyse each part using spectroscopy. So you can see that it's quite laborious. And this is the FTIR-ATR instrument. So spectroscopy is the study of absorption and emission of light and other radiation by matter. It involves the splitting of light and its constituent wavelengths, forming the spectrum of colours you can see in each of the 4 examples. So perhaps on the top right, the LDPE or low density polyethylene has the characteristic bunny ears in the picture, the spectrogram, as opposed to something on the left, PET or PVC, that has more of a more densely packed peaks on the right. So given this reading, the FTIR-ATR technology is able to characterise and classify the plastics or the different materials. So that's kind of how we're doing it. In contacting the manufacturers, approximately 50% responded. However, the information they offered was fairly scant and usually incomplete. You can see that B. Braun's response on the Intracan catheter suggested that it was made of FEP or fluorinated ethylene propylene, which is quite different from the PDMS or polydimethysiloxone indicated by our analysis. ICU Medical was able to state the main materials in their intravenous giving sets. However, this was just 4 out of the 12 that we spliced up from that product. Similarly, Cardinal Health gave just one of the lesser components in their response, and Haynes and many others gave no response at all. Gloves, on the other hand, were clearly labelled with what they're made of. This is likely due to a mixture of regulation and marketing that requires latex to be labelled to avoid allergic reactions. So to some extent, it's understandable that manufacturers don't respond because it's complex. But if we look at this example, maybe on the right of a simple Kurapur dressing, we can see that it's actually made of 5 different materials, and the material ones in volume are the packaging. So it does beg the question, though, why aren't manufacturers doing it anyway? There's a move towards this kind of labelling for medical devices in the European standards. However, progress on this is exceedingly slow, decades in the making so far. So hopefully it will be business as usual one day, but until then, there is regulation in place requiring a company to label the material components of their products and its packaging. This is the option that we're left with. So what have we found to date? The good news is that in ranking the most used items, we're moving reasonably quickly through the top 100, and that they represent 93% of the total volume in the data. The top 20 items represented 84% of the total volume, but only 23% of the total expenditure. So this speaks to the globalised nature of the healthcare economy, with high volume items being produced as cheaply as possible where it's cheapest to do so. But that's not to say that all healthcare items are produced this way. There are healthcare manufacturers throughout the first and second worlds with reputable product ranges that also move globally. However, these are often more bespoke product lines like hip screws or dressings for specialised wound care or enteral feeding sets, etc. And so far, there are no standout carbon hotspots visible in the data. It's more a milieu of plastics, paper, and small amounts of metals in different formation, making an extraordinary carbon footprint by sheer volume, as opposed to any particular greenhouse warming potentials. We haven't come to the inhalers or anaesthetic agents yet, and I'm sure there will be still be some surprises in store as we get through more data, more items. The bad news is that there seems to be a poor use case for recycling within these top 100 products. Most are simply made of too many hybrid pieces of plastic materials and different polymers, which are largely indistinguishable from each other. For a simple example, clear packaging is commonly made of polyamide, PET, HDPE and LDPE, common products. However, they all look the same to the naked eye. Single polymer products are obvious, but not common. Medicine cups, denture cups, kidney dishes, etc. And there seems to be more of a case for campaigns that reduce the number of items used where possible. For example, some of the top 100 include tourniquets, scissors, kidney dishes, pill cups, syringes, etc., where their life can potentially be extended to single patient use at least. Noting that in the literature, the Gloves Off Hand Hygiene Project demonstrated a 15 to 20% reduction whilst maintaining patient outcomes. Further food for thought from the top 100 is using reusables for things like oxygen saturation probes, incontinence pads, hover mats, calf compression devices, and extending the life of products like breathing circuits and feeding sets. I would also like to acknowledge at this point that the students that are also contributing to the development of knowledge within the lab. We currently have 2 honours students, Emma Sim, who's working with Marty Nguyen on waste, Ethan Yap working with Scott on life cycle analysis. We've got Liam, a clinical scholar who's working on a literature review of the legal and regulatory landscape for single-use items and use-by dates. And we've also got 3 student interns, Rachel Wang, Alicia Ong and James Zhang, and 2 volunteers, Vramori Chattopadhyay and Hanchen Yu, all helping to characterise the plastics and create the library. So here's Vramori giving the thumbs up because to date we've analysed 400 products, and that's kind of growing day by day. And yeah, so I hope you can see that there's been a lot of work to produce even the first findings of the lab, and that life cycle analysis is quite complex but fun and worthwhile. So yeah, watch this space and hopefully we will bring you more interesting findings over time as the lab develops its capacity to generate LCAs and build knowledge. Thank you. I'll stop sharing.
Thanks, Catherine. Scott, did you want to do your presentation and then questions at the end of, or?
Yes.
There you go, Scott.
Okay. So I'm just going to give you a quick rundown on life cycle assessment, since we've talked about it quite a bit. Forbes showed you the diagram, just an idea of we've got these interlinked stages of product systems, from getting things out of the ground through to making them use and end of life. So with life cycle assessment, we have the economy or the technosphere. That's the things that we do as humans. So we have things coming in from the environment, so resources, and we have water use and land use. And then we have things leaving the economy and going back out to the environment. So emissions to air, land, and water, so pollutants, different substances, carbon dioxide. And so life cycle assessment is quantifying these flows into the environment and back out to the environment. What I'm going to talk about today is something called process life cycle assessment, which uses these individual processes. So we have things coming into a process. So we have materials. There can be other things from that have been manufactured. They can be things that are from the environment. So there's raw materials, energy. Then we've got things coming out. So we've got products. Sometimes we have co-products, and then we have waste and pollutants going to the environment. And so a merino sheep is probably a nice little example. So we have the things coming in, we have diesel use for tractors, we have fertilizer for pastures. Coming out, we've got 2 products, we've got the wool and meat, and then we've got emissions. So we have methane coming from the sheep themselves, we've got nitrous oxide that's coming from nitrogenous fertilizers. So that's an individual process. So these all get put together into a process tree. So this is an example of a process tree for a UNE. So we have this is heavily truncated. The actual process tree in our software is about 1,000 of these individual little processes. So down the bottom, you can think of that as sort of the raw materials coming in, sort of, and then forming a pyramid with the UNE on top. Our software shows the thicker the line, the greater the impact. So the greatest impact was due to the actual test itself. So the electricity used for the analyzer. Other impacts were the gloves and the vacuum container and the collection tube. Now there's 2 types of process LCA, which are important for you to understand the next sort of little bit. So we have attributional and consequential. And attributional, you can think of a pie, a big pie, and we're looking at, the thing we're looking at is like what slices it of the big pie. So for imaging, like, what slices imaging as part of the total environmental footprint of the hospital. Consequential LCA, on the other hand, is looking at the pushes and pulls for things. So a good example is the increase in electric vehicles. So we have less oil being extracted from the ground, so there's less fossil fuels being extracted, but then we have more mining for things like lithium for batteries. So things push and pull according to market demands. And so if we look at an example of a train, so we have a train, it produces 100 kilos of CO2. So 5 people hop on the train. And the attributional approach, each person is responsible for 20 kilos. So you take the whole, the 100, you slice it into, into the pie segments, each person 20 kilos. Consequential analysis, on the other hand, goes, well, the train is running regardless of whether anyone hops on. It's running to a schedule, it's always running. So the consequence of a person hopping on is the electric engine just has to work a tiny bit more. And so we'll say each person is responsible for half a kilo of CO2. So think about those things when we look at this a study we did on the carbon footprint of imaging. We looked at 2 things. So we looked at that average, that attributional, and the consequential. And we looked at CTs, MRIs, X-rays, and ultrasounds. So the average, that attributional, and then we asked, what is the carbon impact of performing an additional scan? And looking at the energy, this probably explains it a wee bit more. So for the attributional, we took all the energy that got used. So we included the standby overnight energy. Both CT scanners and MRI scanners in particular have to use power overnight to keep them cool. So we included the overnight standby power and included all the energy for imaging. The consequential approach said, well, what happens when you do an additional scan? And so the impact of an additional scan is basically from this point here. So this is like the active standby power. So at the start of the day, machine gets switched on to the active standby power. It's sitting there waiting to scan. So it's going from that base here up to here. So this peak here is basically the consequence of ordering a scan. We also included all the consumables that got used, so gloves, syringes, contrast, the cotton sheets, and the laundry for those sheets for patients. And this is what we found. So the numbers up here are the equivalents in a passenger vehicle. So you can see straight away the attributional impacts of MRIs and CTs is significantly greater than the consequential. And this is just standby power. So this is basically just capturing the standby power of those scanners. The consequential, 103 to 6 kilometers for an MRI just shows that additional power that gets used is actually quite tiny. You can see down here, X-rays, actually most of the impact came from consumables. There's actually very little power used. So that kind of tells us 2 things. It kind of lets us look at things at a system level, going, well, what is the impact of imaging as a whole? But then it sort of answers the question, well, if we stop an MRI scan, what's the consequence of that? And it's actually sort of smaller than we maybe think it is. And we can see a very similar thing with pathology. So we looked at 4 main tests, and again, you can see, maybe unsurprisingly, the attributional is greater than the consequential. Again, this is just like this is just analyzers running overnight in hospitals. But you can also see how important phlebotomy is in collection, especially if you're going, what is the consequence of ordering an additional test? So if you want to reduce the impact of pathology, then not ordering the test becomes important. Maybe noticed down here for CRP, there is only a very, very small thing that you can't see for testing. There's nothing for the collection. That's because they're basically always ordered with U&Es. So the consequence of ordering that C-reactive protein is you don't have to sort of do another collection tube that's already been captured by the U&E. So I just mentioned about the reducing pathology testing is an important thing. So this was a study that we did in St George's Hospital in Sydney in the Department of Medicine. So they had an intervention which basically said we're going to reduce non-urgent testing to 2 days per week, and on other days, if essential. So it was a retrospective study. There was a 6-month reference, 6 months reference period, and then the intervention period. And we saw a 10% decrease in testing over time. There's no change. There's no adverse impacts because of that. That's a similar sort of percentage to what other studies have shown. There's a 53,000 financial benefit from that, and sort of maybe in sort of a surprisingly small.
I think a little bit. Yeah,
And a surprisingly
just
small.
not to your
132 kilos of CO2. But importantly, if extrapolated nationally, that sort of expands out to 56 million and 135,000 kilos of CO2. And I think it comes back to that idea that apart from things like anesthetic gases and metered-dose inhalers, there's very few carbon hotspots in healthcare. Instead, there's a lot of things that get that have at sort of that individual patient clinician level have a very small impact, but cumulatively create this very large impact. So everything that we do to reduce use is actually really, really important, even if you think at the time it's only a very small sort of impact. So thank you.
Thanks very much, Scott and Catherine and Forbes, of course. So I'll call for questions, and I might just start by asking the team, what's your hypothesis? What do you think you guys are going to find in terms of biggest impact? And my follow-on question is, how are you going to roll that out to community healthcare for the rest of us?
Scott, do you want to go first? I'm just
No, you
since
go
proceeded.
first.
Yeah, I think what we've already found from Catherine's and the team's work is that, and I think Scott and I have sort of alluded to this, is that there will be lots of things that there are no silver bullets anymore. They were the anesthetic gases, but yeah, so all those common things that you see every day will be actually important in totality. So it's not an easy process now, but everything starts to matter. So I'm getting calls. You keep going, Scott. I've got a code.
Okay. So I think low value care is kind of like the incandescent light bulb of healthcare. It's the place that we should be focusing on first, because we know that you can do reductions in low value care without adverse health impacts, and because of that. So I think that's kind of a really important place to be focusing our actions.
Yeah, as an example of that, Michael, would be, for example, clotting profile tests in the ICU. Most of the time, they're completely unnecessary after 1 or 2. We've shown that after 1 or 2 days. So there's a lot of things like that that I think are going to be important. Yes, I do think that as we accelerate towards a more green grid with more renewables, I mean, Victoria's already 40% renewable, which is an amazing effort in the last 15 years. That will make reusable equipment better. So that renewables make reusable better will be important, but it'll be like reducing, reusing, and reducing the amount of low value care along the way.
Well, if I may just ask a provocative question, then it seems an extremely sophisticated piece of work to identify the life cycle for each of these items. If you think we just need to do everything a little bit better, what value is there from knowing this really precise, complex understanding of each part of each material's contribution?
Yeah.
So
yeah, you go first, Scott, and then I'll...
Okay, no, I was just saying. So I think an important thing is trying to determine as well what are lower carbon pathways of care. So we can't actually do that without this sort of very precise knowledge of things. With this knowledge, it means that we can get into, we can link our stuff with electronic records, especially with things like surgeries and stuff, and very quickly go, well, here's the procedure. What are kind of the ranges of carbon footprints? Are there sort of different groups or different clinicians or whatever that have a lower footprint than others? Are there things that we can therefore learn and then try and put forwards as an alternative way of doing things.
Good answer.
Yeah, sums it up pretty well.
Irvi, have you got a question?
Yes. I actually have a question for Forbes and Scott, and another question for Captain actually. So my first question was, you mentioned that there was a lot of difficulty in getting accurate data from suppliers, and it can especially be challenging if there are proprietary consumables from suppliers. So what do you think, in your opinion, can improve data availability for such like hospital-specific LCAs, particularly when suppliers are not willing or not really cooperative to share their proprietary emissions data? What do you think can be done? And my other question for Kathy.
Well, maybe just one. Yeah, time. Yeah, you go, Scott. Yeah.
Yeah. So I think an important aspect, and you can see this is happening because of the NHS, demanding that they want data by 2027, 28, is manufacturers are going to have to at some point produce environmental data as part of the procurement process. At the moment, there's not a standardized set of rules for performing environmental analysis, but at the moment, there's a project going on with British Standards to create there's a thing called product category rules for pharmaceuticals. So every pharmaceutical gets analyzed using the same kind of assumptions about, these are the parts of the life cycle that you have to include, and this is the data quality that they have to be. So something similar for medical devices is probably going to come soon after that, I would imagine. So with that, it's going to be part of procurement. So that's how you make manufacturers do it.
Thank you, Scott.
And Andrew, Director of Pharmacy at St. Vincent's, have you got a question?
Yeah, thanks, Michael. Question, anyone on the panel, but maybe Scott, I was thinking of. I can definitely see that the quick wins we talked about, volatile anesthetic gases, etc. They've largely been done, or most hospitals are certainly working on them. And so it now, the journey now starts to get a little bit more complicated because we have to drill down, and we've talked about some of the products which are multi-component products, and so that's a lot of work. And I wonder whether, or what your thoughts are moving forward, where the use of AI modeling sits with this, because it becomes infinitely complex. And so for one individual to sit down, or even a team of individuals to sit down to work through this, it's, you sort of feel like you're a needle in a haystack a bit, and it's just hard to keep up with it. But and I feel a bit mixed by asking it, because we know that AI in itself generates huge amounts of carbon emissions, but that's usually for the training of the models, not for the use of the models where they exist. But I mean, do you feel that is actually going to be the way that we're going to deal with this in the future? We're actually going to build AI models. So if companies were theoretically mandated to expose their ingredients and components, etc., for products, that we could then around that build models that will actually work out the emissions of each product, and then can go and look for solutions to reduce low-level care, all of that sort of thing. Because I mean, they're using it to map genomes, they're doing for all sorts of other things. I would have thought that AI is actually would be an excellent tool in this space, assuming that all of the necessary ingredients were exposed for AI to learn from it, but to actually start to model and to actually look for savings, because that AI can work exponentially quicker and come up with solutions better than any human can. But I just sort of wanted to get your thoughts on where AI sits in this space.
Maybe somewhere in the future. So the problem now is there's just a lack of this very fundamental information. So which is what we're doing. The whole cutting up bits of plastic, going, what are they? It's just like this really, really base level of information. So until you do that, then all these sort of like future technologies and digitals and AIs and things, that is kind of like it's sort of the cart before the horse. And
Yep,
so
yep.
what we're doing is like this really fundamental piece of work to enable these things in the future to use as information.
Okay. So it's really
Yeah,
mandating. It's really getting the
you know,
companies to mandate. Is that where we need to start, getting companies to mandate
Yep.
what their products are made of, so that information is more easily accessible, and then we can build models to start to do these things. Yep.
Yeah,
Well,
basic science still matters.
Yep. Makes sense.
So we might have to move on, unfortunately. I'm really sorry, Carol and Alex. I hope I don't offend you too much, but we're running a little bit out of time. And Ben Dunn, who is a thoracic surgeon from Royal Melbourne Hospital, but also a sustainability giant in healthcare in Victoria, has a really important presentation about something a little different, more of a practical lens on how clinicians can act now and improve sustainability in their healthcare networks. So thanks, Ben.
Thanks very much, Michael. Yeah, a little bit different, but very much building on the work that Forbes, Catherine, and Scott is doing, because it's about taking the massive amount of work that they put in and the really awesome data that they produce and turning that into some real action and outcomes for the health system and for our environment in general as well. And because this is a grand rounds, I thought I'd start with a case study, but instead of a patient, it's actually one of our frontline clinicians. This is a story of one of our surgical HMOs who came to Royal Melbourne and kind of put her hand up to be one of the sustainability reps on our RMO society. We talked about the amount of unnecessary blood tests being done in pre-admission clinic. She didn't have a lot of experience with change management or QI projects, but saw a poster for our environmental sustainability competition that you're going to hear more about. Signed up, and we supported her to undertake a sustainability and QI project last year, and brought about a significant reduction in the number of unnecessary coag tests done in the pre-admission clinic, saving over 60 kilos of carbon and $42,000 for the health system through that. And building on that, success breeds more success. She picked up the skills from that, was keen to start a new project. We brought her along to one of our workshops last year. She got funded by Royal Melbourne Foundation and led another impactful project this year, reducing the number of unnecessary TEDs used across the hospital, saving the hospital $60,000 a year and 1,600, like a ton and a half of carbon. So this is really about empowering our frontline clinicians to use the data that Forbes, Catherine, and Scott produce, combining that with some practical skills to bring about those changes that we really need to start seeing across our healthcare system. And why are healthcare frontline clinicians most important in driving this change? It's because, as you can see the bar chart on the left of the screen there, 80% of our emissions in healthcare come from clinical care and the decisions we make every day as clinicians. And when you combine that with other data that we know, where 40% of the care delivered in Australia is either wasteful or harmful to our patients. So we can tackle that low value care that Scott alluded to, and that's better care for our patients and better care for our planet. And we're focusing on hospital-related emissions, especially with our competition, because this is also more data from Forbes and the team. The bulk of the emissions associated with healthcare delivery come from hospitals. This is why we're targeting clinician decision-making in hospitals to have the biggest impact. But we need ways to speed up the adoption of the evidence. Forbes produces the data, but it takes such a long time for people to get it on board. 17 years is the latest estimate from that. And that's why we bring in, the quality improvement lens. And that's a new-ish approach to bringing change about in healthcare. That's all about improving our processes and outcomes. It's iterative cycles of improvement as we go. It takes place over weeks to months rather than years and years. And it's all about engaging our stakeholders, our frontline clinicians, and sharing information in an organization and between organizations. And that's already recognized in our safety and quality standards for the hospitals. It's recognized in the National Health and Climate Strategy. It's even being embedded into the medical curricula across the UK. As this is one of the important pillars of how we're going to make our health system better, stronger, and greener. And not only does it have benefits for our system and the patients, but it's actually got benefits for our clinicians as well. If clinicians feel engaged and valued at work, they're more productive and they've got less burnout and they've got better mental health as well. And that's been a huge thing that we've been concerned about for the last 10 years of the Beyond Blue reports, and especially coming out of COVID. So what have we done in terms of, turning all this information into action? Well, back in 2022, and, I owe an awful lot of this to Monica Page, who's the sustainability manager at Royal Melbourne Hospital. We were looking to reinvigorate the Green Champion Network and make sure we were all across any sustainability projects that were happening in the organization. We opened up the competition to all clinical and non-clinical staff, let people submit any project they'd done in the last couple of years, did work with our QI team to customize some project management resources for them, and they got some support through our team and the sustainability team, myself and Monica. We weren't reinventing the wheel. This is basically taking the PDSA well-established quality improvement process, but with a new lens to it. It's the sustainability and quality improvement lens that has been developed by the Centre for Sustainable Healthcare in the UK. So it's not just about clinical outcomes anymore. It's also a little bit about the financial outcomes, but a lot about the environmental outcomes related to our healthcare processes and practices. So we were just blown away by the quality of the projects that we heard, that we got submitted. We had 13 projects from clinical and non-clinical staff. There was almost $500,000 in financial savings in the very first year, and 2.5 million kilos of carbon dioxide, largely driven by the telehealth program that got up and running early on in COVID at that point in time. But even on top of that, there was 250,000 items kept out of landfill from these projects alone in the very first year, with only a limited amount of support from myself and Monica. These are some of the examples of it, some choosing wisely or reducing unnecessary tests down in the emergency department and in our cardiothoracic pre-admission clinic. Our telehealth program, as I mentioned, really reducing patient travel and transport, and a huge amount of emissions saved there. And even simple things like reducing the amount of paper used in the revenues department as well. So we built on that and expanded the competition in 2023. Peter MacCallum Cancer Centre came on board. Our neighbours, the Royal Women's Hospital, came on board. And, this time we worked with the University of Melbourne team to sort of ramp up the quality improvement resources that we had to provide to the people interested in running a project. And this time people only had 6 months to complete their project. But despite that, we still had 17 projects submitted, $160,000 saved across the 3 organizations, 140 tons of carbon dioxide, and 3 tons of waste kept out of landfill. And when we've looked back and looked at just the cumulative savings from the clinical projects, not even looking at the cumulative financial savings from any telehealth or facilities projects, we were up to almost $1 million at the end of that second year of the competition running, which was fantastic. And importantly, there had been no adverse patient events reported with any of this work that was done. And these are some of the examples of the projects that were done. Again, reducing unnecessary testing, like Forbes and Scott have alluded to in the emergency department, and reducing unnecessary testing in our pre-admission clinic, eliminating piped nitrous oxide use from the Peter MacCallum operating theatres. All these sort of projects that have both financial and environmental savings for every healthcare organisation. And it was really great to be able to, work with staff across the organizations, make sure they got recognition for the work that they'd put in. They were all really passionate, putting in this work in their own personal time to deliver these sort of environmentally sustainable changes in their own areas. But we listened a bit more closely to their feedback this time on, what we could do to make it even better for the next year. So we had some more formal feedback and evaluation. We said, all the participants that kind of were part of the competition said all the resources that we provided for them were clear and helpful, but they really did want some more didactic teaching on how to run a quality improvement project. They wanted a little more hands-on instruction and guidance. But it did teach us that competitions are a very effective way to get improved workforce engagement and start to produce some results. So building on that again, in 2024 was the third year we ran this, and we moved the competition kind of administration and delivery a little bit more centrally to the University of Melbourne, so we could start to expand even further. And we sort of, called on the University of Melbourne Sustainable Healthcare team to make sure our resources were more up to date. And we worked with the Centre for Sustainable Healthcare in the UK to make sure the university was recognised as a SUSQI training beacon site, the first site in Victoria to obtain that beacon site status. And in October of last year, we ran Victoria's first SUSQI workshop. So we had 50 healthcare professionals coming together. There were doctors, nurses, allied health staff, sustainability officers. It was a half-day workshop. We equipped our participants with the skills to design and then deliver these quality improvement projects with the sustainability lens. It was really fantastic that we had the Royal Melbourne Foundation actually sponsor 12 of the competition participants from 2024 to attend the workshop. And all the attendees reported that they had a better understanding of the sustainability and quality improvement process and felt empowered to go away and actually execute some projects their own. 100% of the people who came to our workshop said they'd recommend it again. And we've been building on the success of that. So we've got another workshop planned this year here in Victoria. We've actually got a workshop planned interstate with Metro North Health Services in Queensland. And we've also developed a partnership with Safer Care Victoria to deliver a bespoke workshop for them, specifically targeting Victorian emergency departments, aiming at reducing unnecessary testing and interventions there as well. So it's been a fantastic opportunity to grow this movement. And we even got nominated as a finalist for the Victorian Public Healthcare Awards for helping to create a sustainable and climate resilient health system, which is really a pleasure to get that sort of recognition at that scale. And now, hot off the press, we have the results of the 2024 Health Service Environmental Sustainability Competition. I can't go through the details of any of the individual entries because we haven't announced any of the winners yet, but we had 14 really impressive quality improvement projects, 12 of them being purely clinical change projects, with an unbelievably impressive $770,000 saved across the 3 health services. 83 tons of carbon dioxide, 1.7 tons of waste, and over 500,000 items kept at a landfill. And when we look back and re-audited the clinical projects over 2022 and 2023, we've now cumulatively saved, over 3 years, saved the 3 health services $2.1 million as an estimate. So it really is a testament to show how much this can grow and scale over time and continue to build momentum and impact. We've learned a lot of lessons, but the really positive things are that these competitions really can serve as an excellent engagement initiative. They really do generate meaningful environmental, financial, and social savings. And, frontline clinicians and staff are really eager to engage with these sustainability initiatives, particularly when you give them some support, provide access to training as well. And it's a fantastic example of, these might feel like small actions. They might feel like small local clinical change projects, but done across a lot of people, it really does start to add up to big change. And when we're talking about big change, we're, really are demonstrating how our impact is going to continue to expand. In 2025, we're going from 3 health services to potentially up to 10 health services taking part in our competition this year. We've already got the Children's Hospital, the Austin Hospital, St. Vincent's Hospital, and Mercy Health committed to being part of our competition this year, as well as the Ioneer, Northern and Western, looking like they're very likely to come on board. So this is going to launch on World Environment Day, June the 5th, with a project showcase event held in Parkville. So make sure to keep an eye out for any opportunity to get involved through your health service. There will be some more comms and advertising, about our competition once we launch. But if you work in any of the places that have already committed to getting involved, make sure you start thinking about your project. If you're in one of the health services that hasn't necessarily committed just yet, make sure you advocate for your health service to get involved. But that's not the only way you can start to work with us. We're going to be running another one of our sustainability and quality improvement courses this year. It's going to be on the 6th of August. This is a QR code that you can use to register your interest. So when we actually start to open registrations for the course, we'll be able to reach out to you directly and make sure that you get a spot on the course this year. There's also a number of other networks across the University and Medical School for people interested in sustainability and healthcare. There's the Melbourne Medical School. Our sustainable healthcare team runs the Sustainability and Planetary Health Action Network. That QR code there takes you to another EOI form if you want to get involved with the network. And it also gives you an opportunity to register interest with the Climate Catch Lab, which has been a really fantastic collaboration between the Faculty of Medicine, Dentistry, Health Services, the Melbourne Medical School, the Melbourne School of Population and Global Health, as well as Melbourne Climate Futures, to tackle a number of initiatives related to health and climate, and sustainability in healthcare being one of those important streams. But thanks everybody for tuning into the Grand Rounds. I hope this has given you a bit of a window into just how impactful we can be when we work together and how frontline clinicians really can lead sustainable change. Once again, if you want to be part of our SUSQI workshop in August this year, there's the QR code to register. And yeah, thanks very much for the opportunity to present today and show just exactly what's possible when frontline clinicians are given the tools and the data to be able to go out there and start to run some sustainability in healthcare projects. Thanks very much. Back to you, Michael.
Thanks, Ben. Great presentation. I'm sorry it was a little bit shorter. Not very good chairing on my behalf, but thanks again for your presentation. I absolutely am inspired
We're
by
still on time.
I'm inspired by your passion and your ability to sort of think big. It always makes me feel that I'm doing stuff, but on a really small scale. And I just love how you always try and translate it to a healthcare network or a healthcare service and then spread that so that your impact is really magnified. It's really fantastic, mate. Well done.
It's been a fantastic team effort. The Melbourne Medical School Sustainable Healthcare team, I mean, Sonia Chanchalani has developed and delivered these sustainability and quality improvement workshops, and it's really been her that's led the development of those and getting us established as a beacon site. And the support of, you know, Forbes and Eugenie Kayak and everyone else has really been invaluable.
Don't be too bashful. I mean, I started this meeting with a reflection on one of my colleagues and anaesthetist talking about the loss of nitrous, and one other thing you said was, you know, does it really make a difference, these tiny little things that we do in our healthcare network? It's just a dot in, you know, in a giant problem. But actually, as you've shown, you know, a little dot here and a little dot here, before you know it, it's a big impact and hopefully a big step towards a solution, you know.
Absolutely. Yeah, it all adds up, and adds up a lot quicker than we would think it's going to. Yeah.
Probably got time for one or two quick questions if anyone's got any for Ben. I've already taken a screenshot of that QR code. How many people can go to the course, Ben?
There's probably room for at least 50 or 60.
Sounds good.
And if we've got lots of demand, we can always do more.
Any questions for Ben? Well, Ben, I guess the hardest thing, you know, we're excited about St. Vincent's participating this year, and I guess the thing that makes me a little bit nervous is, you know, calculating those really precise gains. But I might lean on Carol to do that for me, I reckon.
I think you've got Carol. You'll be fine.
All right. Well, if there's no questions for Ben, then we'll close the meeting. It is 5 o'clock. So again, I'd like to thank everyone so much for joining us on this Wednesday. Our next meeting is, as I said, in July. I'll send plenty of comms before that time. There are email lists. Please feel free to join the lists, share them, send them to your friends. And again, any comments and feedback, please feel free to reach out and get in touch with me directly. Thank you very much, everyone. Thanks, Forbes team. Catherine, Scott, and thanks, Ben.
Thank you. Thank you, everybody.
Thanks for organising, Michael. Cheers.
Thanks, everyone.
Cheers. Thank you. Bye.
Thank you.